what's new? And in the circle is what's new. On this page is what we had since quite a number of years. This page is with Einstein and without Gauss. And this page is what happened with Gauss, with rediscovering Gauss' unnoticed unification. I present it without the proofs because it's 30 minutes of lecture. I make sure I make all crucial statements and need a clock to check it. And we have time enough in the disputation and in the discussion after to go in any depth of any part. But I want to make sure that I have the top of it and also the unity achieved. And that it really, that I can prove that it is the law, capital, before the laws, and before the laws of all our exact sciences since the time of Gauss, so since the 1830s, where they all came up. I put the poster on before Gauss and after Gauss. And before Gauss are all these big experimental things and all the things related to life science and even the transition to brain theory. They are already there, and I focus on, I call it uncertainty from second law, and as based by Planck and Einstein for quanta, and I make the key point that exactly the same mathematical formula and of the same physical meaning on which quantum theory by Planck and Einstein was based, to Bohr, Heisenberg come later, after Gauss. Exactly the same formula, no different meaning, no different problems, no different disputes about, is the origin, the physical origin of catalysis, is a physical origin of action potentials. So we have here the three key paradoxes of physics, chemistry, physiology, and the brain or medicine or so we hang on later. And I call it uncertainty based on the formula in Einstein's form, second derivation of entropy, because Planck's form is a special case when these two variables are only one, only energy. And in this identity of the physical law at the foundation is implied life from physics alone. And it's not just an application of some physics, it is the very law which originates. And it's in the sense as Planck and Einstein have originated the quantum age, the dualism wave-particle, and all opposite kind have these paradoxes which Einstein could not solve. He proved them as paradox. And I don't give these proofs. I take you trust me now. You ask in the disputation about. So they have proven this law, and it is the the second law of thermodynamics in the well understood meaning, which has a lot of discussion, which I don't touch now. And it's that law which here Planck and Einstein stand on top, and in catalysis Berzelius, with a statement shortly after Gauss that catalysis is caused by the unimaginable motions at the surface of molecules, which we put with fewer experiments to the top of quantitatively using for the first time this law to predict and quantitatively predict what's happening, and within the precision we have available all crucial experiments which could have falsified it, verified. And it's the catalysis of all biological life enzymes we have tested so far. And the same is true for action potential. And I go in all detail in the discussion. It is the nerve action potential, can be no doubt. And all the discussion, we have an hour time for that, because I want to prove the unity which has been achieved, and that it is a unity without paradox so far. I bring at the end some questions which are of course not answered, and where I can try to put it in form of a paradox, we will see. Of this, without Gauss, unification of life with non-life, only on the basis of Einstein's form of entropy law, of this unification we make already the key point, which will then even be further when we come to Gauss, of the observer. And I want to put the key point on the highest position I can put it. Namely, all in one at the end, followed by all the great thinkers, even in other cultures. That I can say, not in the same form, but in other cultures as well. And this all is that problem which we go through with physics, is the observer's free choices. This I point on, and I will give 3 examples. I want to put it on the same level as 3 fundamental examples, where the observer had a free choice, not always free, sometimes historically it just couldn't be done, but it is a free choice, and where this was the origin of the most fundamental paradox and the most fundamental revolution in science, and now is again. So I give 3 examples. The first is Copernicus, and the second is Einstein, and the third is Gauss. And I put the I because mathematics we have developed, and I constrain myself on theories that have been put to mathematics, just not to get in languages and non-transducible and so on. It was always the I. I put it in that form. One can put it otherwise. It was always the I. So I first place the I and have the free choice, I say now, to have this I on our planet. And have the greatest question, the heaven. The greatest we are to understand, and heaven and earth have no way to be related, and it was even unspeakable, and it was unthinkable. and this will be in all 3 stages, the same thing, that that I could even only imagine to be away from my planet and looking with my eye on my planet and all the humans and their eyes observing the heavens. I look from that. It's the simple step that the observer's free choice was by some event possible to realize and look on the observer, and to have the greatest paradox, the greatest absurdity, and the greatest breakthrough in science of all. So it's 3 taken out, and you have others. Well, that's great. Okay, now I go to the second step, and I do things with the eye. So obviously I do it with light. And I have, once I understood heaven and earth, I've unified, which is not necessarily a better world. It may not be. We may still need all these Greek gods for important things. And now I do the same thing with the same eye, by which gave me the light, and with the light I looked at things, including time and space, my clocks and measurements, which I had learned when unifying heaven and earth. So I decide, once again, I moved away from the earth, but I did not, any time before, just place my eye on a light ray. I put myself there. From the viewpoint of the light ray, I look on all these humans on the earth who had made a Copernican step, were looking on their clocks and have puzzles which they can wipe away and wait for centuries if they wish. In that time it was not many centuries. But it's again the eye and just where it's located. And the moment you sat there, the only one who first did this absolutely correctly, nobody else, was Albert Einstein. Very young, and so we know the story. So now we have a second time done exactly the same thing, and the observer's free choice not to sit on the light, but on the earth, which he solved. And now he makes a second step and sits on the, we don't go into detail, and then all of a sudden we have the revolution of relativity and so on. I will do then later, in the second talk, exactly the same thing. We have then solved heaven and earth. I have now 10 minutes or more already.
No, you have 13 minutes. You are done 13 minutes. You have like 20 minutes.
Yeah. And we have got the Newtonian, the time and space. We have done the light. Time and space is out. And we have already a mathematics which we conceive in our thinking and not by observation. To look at that. And now with that mathematics we arrive in 2 world views, uncertainty and certainty, and we find no way, not a single soul ever found a way, except, as I rediscovered, Carl Friedrich Gauss, and nobody had understood him. I left this as a statement, we discuss it. And then we make the same step once more, but then we go finally, and that's the last thing of what I now just did, we go with our eye, not just in the brain, we go in Gauss' brain. and take from all what he stated, all what he did, and of course compare with something we can do today. We measure brain almost everything, and that will be the second part of my 30 minutes. These are the three big points. I come later at the end to my brain theory, which I already had developed, where these same things which brought me to brain theory, namely that the observer's free choices create paradoxes, such as collisions in the brain, but many other kind, and that they have three and only three solutions. I postpone to the discussion period. This is an exact symmetry solution. I can extend it by three principles, and I name them now first for everybody, that the cortices introduce terminologies. Terminologies. It must not be words, can be mathematical symbols. And they are creative, and they try to unify as much as they can, because they are cortices. And these three principles, which I state now, are the only ones to prove. These are, for example, the EG is very important here, located in the first layer of cortex, in the third, fourth layer, and in the input and output of cortex. But they are also located in the middle and are located in totally different things. Like I don't go into now. So that is the point. And the key point is, when I derive this in brain theory, is the inseparability of these three. They are not separate principles. It's one principle. And it's no other principle than the equilibrium in two dimensions. I have not yet mentioned two dimensions, that I stress, and for people who are not so much in it. And I can apply these three principles, in other words, to dissonances, harmony, variation, and composition. And I can bring it in all these fields into logic and other, which I avoid now. I say it's a law before the laws. So I do not do more now here on the old thing. For me, it's the old thing. For almost everybody, it's a new thing. So I have to add something before, where all this Newtonian or whatever was before, where the same step has been made here. But I abbreviate now and say that we have. And I make now the big step to Gauss. So all this was unified by uncertainty. This was hidden by discussions about entropy, misunderstandings, which I enter in any desired detail. But there was only one correct interpretation. That was that of Gauss, who did not use the term entropy, and that was that of Einstein, who, after even Boltzmann's ups and downs in questions like time a priori or so, has wiped it away and made the final point for me. That's what I say. There came nothing, and the whole non-equilibrium thermodynamics we can discuss in the free discussion or whenever you want, does not exist as a foundation. So now comes the step which I did last year, after having seen it now 14 years ago and noted it, but not been sure of it and totally convinced that this, there must have been people thinking about whatever. And last year I decided, for reasons which I leave to discussion, now to go to the end and to go through the best archives in the whole world on Einstein, Gauss, Berzelius, Nobel lectures on exact sciences, and of course Göttingen. So this I did last year, and with the conclusion that I proved that there will be no grave or no ashes in an urn wherever will come out evidence, a document that any single soul had understood Gauss. And at this point I make a question to you. There was one person but there was only one person, and this I proved. There was only one person from 1829, when the whole thing was written down, till today, who had understood Gauss. And I let you, and I let them debate, I let all of them debate. And not anyone came to it. Of course, thinking Einstein, Riemann,
Gauss.
It was Gauss himself. And this I prove. You see it in details which I don't extend now. So now I make as a statement what Gauss himself states that he has done, and nobody should expect that he will correct it immediately, because the statements have been read, the things had been printed, and there were people like Sommerfeld, like Gauss anyway, like Einstein anyway, and like mathematicians who went very, very deep, including my teacher in university, Ulrich Stehlinger, to us third semester, saying Gauss, Prinzip des kleinsten Zwangs, as if it is a big holiness, which I never left me, this statement, although I could never make any of these deep senses. And I just say now, the key of what was never understood, what everybody will have, even with language, even Robert had yesterday. But it took 200 years. I mean, now I have to avoid that it takes 200 more years, because that's very easy. So, Gauss conceived and created a mathematics. You call it mathematics, it had nothing to do with the other mathematics. Like Aristotle had nothing to do with the other. Like Leibniz had nothing to do with the other. Like Euler had nothing to do. And Lagrange had a little bit more to do, and there came the paradoxes immediately. So Gauss created a theory of uncertainty, of which he proved, and I hope this will take a long time in the discussion period, he proved a law of uncertainty, of an uncertainty which you can never wipe away. You can never get loose. He proved a law of such an absolute uncertainty, which he proved with complete certainty, and which itself is completely certain, without any error. This, I should have now 20 minutes just to let you sit on that thought. It sounds crazy. You have complete uncertainty, and you think up, you create an argument with which he, not yet 20 years old, not able to write this argument, but by playing in this way with it, he was the only one who won the Academy Prize of St. Petersburg, to predict at which time the series is coming back. And he did it exactly the same way. I don't go into that now, I just say it. And this is the first time everybody, since quantum came about, wanted, when the uncertainty seemed to be clear, to get rid of it, or he wanted to create it from something which is certain, as did Einstein, from relativity. But nothing, all failed and had to fail, as I will prove now on a very fundamental, most fundamental way, on the law, before the laws. And the point was this, that I say it now, the key points, just to have said it, but not that they are understood. It's so different, I think. That he started with uncertainty. He did it in a way that the arrow must always be positive around a mean, what he did the first time. And he distinguished the arrow, those arrows which you can make better and smaller, by better instruments, taking care, by imagining I have understood these arrows and I can completely calculate away. So, and he, he did what nobody else did, first having a second term forever, for this part when you have done everything what the experimenter can do. And you say, I treat them as if they do not exist. I have no error. I imagine errors which I don't call error anymore, which I have no way, by no means, and will even by my solution have no means to wipe them away. I do not get rid of the error. And still, I get complete certainty of a law with certainty, with no error. But I don't start with the eye from the observations anymore. I start in my creative brain by realizing, and there is Gauss is superior. I cannot reproduce how he did it as a youngster. I can pedagogically say something later, how I put it in a frame which it looks conclusive, but he did something much above that. And showed that, and the shortest way to prove that is to take his title of these 1820s papers, only on the uncertainty. We don't have yet the unification with the other worldview. Theoria combinationis observationum, in numbers, erroribus minimis obnoxiae. I have to combine these numbers until the uncertainty is minimal. In the title he has erroribus because it needs some effort to get into that. And the key is you only introduce numbers which have uncertainties. You take it with his whole uncertainties, and you never get rid of the uncertainties. Then by combinationis, making of two variables, two new, you can do algebraic things. The new variables still have uncertainty, but they is different in size. And it can be bigger, it can be smaller. And you have an infinity of possibilities, but they never can be zero. in order to be zero, all uncertainties had to be zero from the start, but this was his a priori to imagine uncertainties you can never get rid of, never. So he ends up exactly by that Kombinationis where the uncertainty of these optimally combined observations is minimal and is not zero, but exactly. And this exactness is without error or uncertainty. But if you would still introduce more words for it, which you should, then everybody will have lost it. Even so, nobody has taken it. Not a single soul. So that's the point. More I don't say.
Mm-hmm.
It should be now 25 minutes.
Yeah. So may I ask a question?
No, after
okay.
30 minutes.
Oh, okay.
Yeah.
Mm-hmm.
So I summarize. In first principles of the brain, which follow from Einstein's uncertainty theories, which bring me to the history of entropy and to the origin of action potentials and to the annihilation of collisions, to be discussed, I find three and only three, exactly three principles in the brain, which I see here, realized, and which I predict as my philosophy proof. And Aristotle's expert said, if that is true what I say, I claim it must underlie anything which ever can be thought of. Not the content, what I think, but it must underlie. So any thought who differs from it is, would falsify the theory. And this I'm now 30 years after, 20, 25 years after that event again. So I have now Gauss introducing the erroribus minimis by Kombinationis observationum, but the big point then is on top. He cites in a statement at the end of 31st January 1829, as is sehr merkwürdig, very curious, that in the thinking of the calculating mathematician, but it's him, not any of the others, he had done this exactly the same way as others have long done what we call least path and the origin of geometry to know what is a straight line. And he had done it the same way in the brain. And I close now my short 30 minutes exposure of that by stating from discussion that I prove this from this brain theory. Although it was made without Gauss. It has exactly three of these principles which I observe, and I have, and this is very new, then I did this now, and I say now for a while I hope it will be fine. And I realize when I go to numbers, and I'm limited there, what I can do with them. And then I have an order in these three principles. The most frequent is this ignorance principle, which is composition in music, or which is unified, if I take the whole thing. And but where the key point is ignorance and not having it at all. And then what is dominating the whole cortex and that is the doubt, where I approach truth. These terms only then come up. And this doubt, when I limit it to numbers, as Gauss did, and then it is a variation, like in music. Mm-hmm. But it can be a very different variation on a different level, again and again and again. This whole thing goes, and I limit myself to two of these variations. The one is the variation of that thing which I call ignorance, because it ignores almost everything. But I take something in the simple way, measurements without error, in the other measurements without error, but not coming to the idea of uncertainty. And a lot is hidden behind this simple S, which all of a sudden came up, and later the variation came up. So this is that principle, and then the principle of a law, which holds in the laws. I put the integral. I put things together there. Now, this is a limited, but I have things where these words don't suffice, and mathematics does not suffice. And now comes what Gauss had and nobody had. Namely that this S is something which carries with it an uncertainty which one cannot wipe away. You can never by no means get rid of. So these numbers have an uncertainty around, carrying around, which you can never get away. And you have only thought of, but you found exactly a law. And on top you find that this law, you thought up exactly the same way as you did geometry before, which he does on curved surfaces. I leave these details away. So here we have with Gauss an unspeakable and unimaginable step upwards to a unity at a time when nobody could really deal with it. Although, of course, he was fighting Lagrange, but I leave this. So I finish. Mm-hmm. What's new? Okay, as long as I don't see that Einstein's law for quanta solves the paradoxes and gives the origin, then this is new enough to stay with it. And we did it for 20 years, and we still stay and have to stay with it, and basically the experiments are on that level. But while paradoxes in action, potential and catalysis are solved, the uncertainty in quanta is not solved. For that, I have to move the eye into the brain of Gauss, and I can even formulate this key law before the laws in terms of observables in the brain in a high form of abstraction. So, if I hang on, which I don't, that only after Gauss, and not in the way Gauss unified, but in the way Lagrange disunified, all our sciences, which determine the Nobel Prizes and which are exact sciences which have been developed, came up at all. And we see in Berzelius a lot of Gaussian thinking, but he did not know him. Mm-hmm. So we had 200 years without Gauss, and these were extremely successful for science, because this way to start with the observer is most successful. If I do experiments, I want to see reality. So I open the eyes, I have new instruments. It's the greatest excitation. And if I'm in the experiment and I'm able to put the mathematics from a different world, humanities, then I have fulfilled my dreams. And I only can see that until Copernicus there was a Halley comet, and until Einstein there was a funny property of light. And for 200 years, there was, whenever the theories came there, law of excitation with Galileo via all the stages, put the same time a priori, Gauss fought against Lagrange, and catalysis, except for Berzelius and a few, put the clock next to it and were amazed and thought in space about specificity. And the quantum theory we all know. So it's exactly the same history, and therefore one can also conclude it will not be the last step. There's no reason why, although we have now even the formulation of this law before the laws, we see immediately, if we come to music, we can put the brain principles in it, but we cannot put this formula in it. Because the variations are still above. If the colors are putting vibrations in the tune and erasing motions. So that will continue, and is a big history of our science. And now it's probably 40 minutes. 40?
Yeah.
Okay.
Yeah. Good.
Okay.
Like this.